Hello, students. Have you ever wondered why you feel a jerk forward when a bus suddenly stops? Or maybe why it is so much harder to push a heavy box compared to a light one? Well, the answers to these everyday questions are found in three very important ideas in physics: inertia, mass, and momentum. In today's session, we are going to break down these concepts one by one and understand how they affect everything around us. So here is our plan for today. First, we will try to understand what inertia is. Then we will see how mass is related to inertia. After that, we will learn about a new idea called momentum, which is what happens when mass starts moving. And finally, we will connect all these three concepts together.
Okay, let's begin with our first topic. What exactly is inertia? You can think of it as an object's laziness, its resistance to any kind of change.
Let's start with something we have all experienced. You are sitting in a bus, and it is moving smoothly. Suddenly, the driver applies the brakes. What happens to you? You are thrown forward, right? But have you ever stopped to think why this happens? What is the physics behind that sudden jolt?
You see, when the bus stops, your feet, which are touching the floor of the bus, they also stop. But what about the upper part of your body? It was moving along with the bus, and it wants to keep moving forward. It resists this sudden change from motion to rest. That feeling of being pushed forward is your body's inertia.
So this brings us to the proper definition. Inertia is the natural tendency of any object to resist a change in its state of rest or of uniform motion. In simple words, if an object is not moving, it wants to stay not moving. And if it is moving, it wants to continue moving in the same direction at the same speed.
Here is a simple experiment that shows this beautifully. If you make a neat stack of carom coins and then use the striker to hit the bottom coin very quickly, look what happens. The bottom coin shoots out, but the rest of the stack simply drops down in the same place. This is because the inertia of the other coins makes them resist the motion. They want to stay at rest, so they just fall straight down.
Here is another nice trick. You place a card on a glass and a coin on the card. Now, if you flick the card away very fast, the coin falls straight into the glass. Why? Again, it is because of inertia. The coin was at rest and it resists the sudden motion of the card. By the time it can react, the card is gone and gravity pulls it straight down.
So we now know that all objects have this property of inertia. But do all objects have the same amount of inertia? For example, does a small cricket ball have the same inertia as a huge truck? Let's find out in our next section.
Think about this from your own experience. An empty shopping cart is very easy to start moving and also very easy to stop. But what if the cart is full of heavy items? It takes a lot more effort to get it moving, and once it is moving, it takes a lot more effort to stop it. What causes this difference?
It's the same idea here. Imagine you kick a football. It will fly quite far. But now, imagine kicking a stone of the exact same size with the same force. The stone will hardly move, and your foot will hurt a lot. The stone has much more resistance to changing its state of rest. In other words, the stone has more inertia.
So we can see a pattern here. The full shopping cart and the heavy stone resist changing their state more. This is because they are heavier, or as we say in physics, they are more massive. And this is the key connection you must remember. The more the mass of an object, the more inertia it has.
So this gives us a very clear way to understand mass. The mass of an object is simply a measurement of its inertia. If an object has a large mass, it means it has a large inertia. It will be very difficult to start it or stop it. And remember, an object's mass is always the same, whether it is at rest or moving very fast.
All right, now that we have a good understanding of inertia and mass, we are ready to learn our next important concept, momentum.
Let's think about this situation. A huge truck has a very large mass, but if it is just parked, it is perfectly harmless. On the other hand, a small cricket ball has very little mass, but if a fast bowler throws it, it can cause a lot of damage. So the impact of an object seems to depend on more than just its mass. What else is important?
To explain this, the great scientist Sir Isaac Newton came up with a very important idea. He said we need a quantity that considers both the object's mass and how fast it is moving, its velocity. He called this the quantity of motion, and today we call it momentum.
The formula for momentum is actually very simple. We use the letter p for momentum, so p is equal to the mass m multiplied by the velocity v. That's it. Momentum is simply mass times velocity.
So you see, both mass and velocity are important for momentum. A small bullet can have a huge momentum because its velocity is extremely high, and a very slow-moving truck can also have a huge momentum, not because of its speed, but because its mass is so large. And one more thing, since velocity has a direction, momentum also has a direction. It is always in the same direction that the object is moving. Here is a perfect example from cricket. When a fielder catches a fast-moving ball, they don't keep their hands still. They pull their hands back with the ball. Why do they do this? They are cleverly increasing the time taken to bring the ball's momentum to zero. And by increasing the time, they reduce the force of the impact on their hands. It's a wonderful application of physics.
Okay, now for a quick summary. Let's connect all these three ideas together so that you can remember them easily for your exams.
So just remember it like this. Inertia is the property, the resistance to change. Mass is the measurement of that property. It tells you how much inertia there is. And finally, momentum is what you get when that mass is in motion. It tells you about the impact a moving object can have.
And I will leave you with a question to think about. This question connects all the ideas we learned today: inertia, mass, and momentum. We will discuss the answer to this in our next class when we study Newton's other laws of motion. Thank you, and I will see you next time.